Hi, my name is Dan Weitzner, and I'm the co-founder and VP R&D of WPSemantix. Our company brings about a revolution in the field of databases and knowledge management, similar to the one brought by Apple to the world of computing. This is a story of how we turn SQL engines into knowledge machines. Storage of information has always been key to computing, but how do we store and represent knowledge? Since 1970s, companies like Microsoft and Oracle developed relational databases that organize data in columns and rows, and it can be stored and retrieved using a language called SQL. Today, relational databases have the largest market share by far, and they are all powered by SQL. Since 2001, a new kind of database was developed to represent knowledge by using connected or relationship-rich data. These databases allow embedding data with logic or reasoning capabilities, and as of today, there isn't a single standard graph query language, and the ones available require highly skilled personnel to use them. 9 out of the 10 most value-creating companies use knowledge graphs. Why? Knowledge graphs give them a significant edge to discover patterns or relationships in their data, and they use this knowledge to make strategic use of it and gain significant competitive advantages. They also use this knowledge to expand their businesses beyond their original boundaries. And we as users feel this every day. These companies have spent hundreds of millions of dollars inventing, developing, and maintaining their knowledge graphs, which use specialized languages and require highly skilled personnel to use them. Our solution, Timber, brings about a revolution to the world of databases by creating a virtual layer over relational databases to give them the main capabilities as knowledge graphs do. Timber's magic is that it uses the standard SQL language, so any computer science undergraduate can learn it in a matter of days. And by being a virtual layer, Timber does not require the costly process that knowledge graphs do. And most importantly, it can work directly over big data SQL engines. So what problems do we solve with Timber? We avoid costly migration from relational to graph databases, which is significant in terms of time and money. We facilitate the work on complex analytics over big data. We enable knowledge sharing and the reuse of knowledge in the organization. And we enable data warehouses and data lakes with inference capabilities required for complex analytics and machine learning algorithms. What value we contribute, you may ask? Very important for complex analytics, Timber simplifies complicated SQL queries, eliminating the elements that require the most development attention, branched union statements, and entangled join statements. We can make any relational database ready for cognitive computing, which according to DARPA is the third challenging stage of artificial intelligence that enables machines to communicate with each other just like humans do. Many years ago, in the era when IBM was king, working with big corporations, people questioned Apple. Why would people in small offices need computers? Apple and others showed them why. Now people ask us, why databases need inference? Well, the future is here and is telling us why. And this is how Timber will change the world. It has taken graph databases more than 15 years to gain a minuscule 3% of the database market. But we're going to change that. With Timber and using the widely known SQL, any relational database can gain the advantages of knowledge graphs, such as relationship modeling and inference, without need of undergoing any transformation. And in this way, Timber can potentially transform 75% of the database market into knowledge machines. How does it look? Let's give it a short review. Timber includes an intuitive application for modeling, exploring, and querying the data. The first step is modeling the data, which is a process known to database administrators, very similar to the creation of a database schema or tables. Connected concepts replace the common data fields to represent relationships. Using SQL, concepts are enriched with logic and/or calculation rules to make them smart. Once we have a model, The concept can be queried using SQL, making analytics much simpler. The fact that the data is connected and smart means it acquires characteristics, among them inheritance and inference. These characteristics provide an incredible benefit for complex analytics. Using Timber, the length of SQL queries can be significantly reduced in comparison with the same queries without Timber, thus reducing development complexity and time. And since Timber is a virtual layer, integration is seamless between the underlying data infrastructure and the BI, analytics, and query solutions, and is available to be queried and modified by any machine learning framework that supports JDBC. Most importantly, companies can use Timber concept modeling rules to manage, share, and preserve organizational knowledge, and take advantage of its reasoning capabilities to facilitate the implementation of artificial intelligence initiatives. Timber can be implemented on the cloud over the big data engines and on-premise over local instances of SQL engines. Timber applications are very wide, and as time goes by, more and more companies will find creative ways to use it. In current uses of knowledge graphs include complex analytics, cognitive computing, investment model testing, digital campaign optimization, recommendation engines, fraud detection, and more. Therefore, Timber can appeal to a great variety of markets. Enterprises integrating heterogeneous data, enterprises migrating to big data, enterprises implementing IoT models, research institutions, financial institutions, healthcare and pharma, government institutions, and in general, any enterprising doing BI and complex analytics. Thank you for listening, and I will be glad to answer any questions or comments you may have here through email or through our website. Thank you.